Other questions?
So to be clear, we only need the tools in 3.10 if there's multiplicity more than one?
Sometimes multiplicity more than one, but we do not need 3.10. Once again, please take a look at this example, section 3.8. Over here, one can check that multiplicity of 2 is 2. But because the corresponding eigenspace is two-dimensional, we do not need section 3.10. So in other words, the title here is misleading. One can get the impression that if roots are equal, then we have to apply long formulas. Absolutely not. We apply tools from section 3.10 only if the total sum of dimensions of eigenspaces is not equal to n. Does this make sense?
Absolutely, thank you.
I was just wondering, is there a way to determine how many different, or how come it's like that? Like, is there a way to see without actually going into with that?
So your question is, suppose we have an n by n matrix, is it possible to know quickly we need section 3.10 or we don't need section 3.10? No, there is no way. We have to find the dimensions of the eigenspaces, and then we will see.
Okay, thank you.
I was wondering for like, so let's say you have a matrix. However, let's say that the vectors inside this matrix are linearly dependent. So if we have this linearly dependent set of vectors, does this have an effect on how many independent or dependent eigenvectors that we will get?
Good question. Basically, there is no clear-cut relationship. Think about this. Let us consider the following matrix. Column number 1, 1, 0. Column number 2, same, 1, 0.
Okay.
Let us find the eigenvalues.
Yeah.
So subtract lambda from the main diagonal. We'll get 1 minus lambda and negative lambda on the main diagonal. Therefore, the eigenvalues will be 1 and 0.
Yeah.
The corresponding eigenspaces will be one-dimensional, and we do not need section 3.10. We have two distinct eigenvalues.
Yeah.
Therefore, we will be able to find two linearly independent eigenvectors, despite the fact that columns of our matrix are different.
Okay. Yeah, that makes sense.
Does this answer your question?
Yeah. Thank you.